Welcome to physics lesson, and in this lesson, it is our first lesson to many other lessons which are on the way. I want to introduce you to physics Form 1, and I will take you all the way up to the last topic in Form 4, which we call it electronics. It will take me like 150 lessons. So this is like the first of 150 lessons that I'm going to take you through. So I welcome you to Ambassador Foundation YouTube channel, Ambassador School. Feel free to learn, comment, ask a question. My friends, my colleagues, and myself will answer you. So this is just the introduction. So when you're done with this lesson, you just check for the next. I'm indicating it as the first lesson, as the second lesson, all the way until we are done with the physics syllabus. Also, prepared for you is the chemistry syllabus from Form 1 up to Form 4. Feel free to share with your friends, with your relatives, and anybody you feel like he or she should learn physics, introduction to physics. So, first of all, physics is a branch of science, and that one we know. In primary, we were doing science as a whole subject. But now in high school, science is wide. So that's why we have to divide it into 3 branches. And one of them is physics. The other one is chemistry. And the other one is biology. Physics and chemistry are referred to as physical sciences. And biology is the biological science. That is just the introduction. So physics is defined as the study of matter and its relation to energy. We study matter and how it relates to energy. But now, some of you will confuse the definition of physics and they write that it is the study of energy. It's not. We don't study energy with relation to matter. We study matter and its relation to what? To energy. It involves explaining of a mysteries or phenomena such as the falling of bodies towards the ground. Why is that when an object falls down? When you throw an object, it comes down and not up. We will explain it in physics. We will also explain why there is a rising up of liquids through a drinking straw. Yeah? When you want to take soda or your favorite drink, use what? Use a straw. How is it possible that the soda will rise up through the straw? It is physics, and we will explain it. Seasonal occurrence of tides. A plastic pen wrapped against fur or air picks up small pieces of paper. A crackling sound is heard when a nylon cloth is removed. All this we will explain with the knowledge of physics. Let's follow one by one. When we study physics, it entails very many things. Anything that is part of physics is what we are saying physics entails. So the study of physics entails the following: the measurement of quantities and collection of data, drawing and testing of hypotheses through experiments and observations, establishment of laws and principles. As you are studying this physics, we are going to collect data, we are going to analyze data, and after analyzing the data, we come up with what we call the laws and principles, which are going to govern us in most of the topics in physics, here in high school and beyond. Also, physics is wide, so we have to subdivide into what we call the branches. Some of these branches later on becomes the topics that you're going to study. So, for example, when you look at, when we try to look at a branch like mechanism, it's also called mechanics. It deals with the study of motion under the influence of force. So there are many topics that will fall under mechanics and mechanism. We have another one called electricity and magnetism. We have a topic of electricity. One in Form 1, another one in Form 2, another one in, one in Form 1, Form 3, and Form 4. Magnetism is entirely done as the first topic in Form 2. So what does electricity and magnetism entails, or what are we supposed to study, or what are we supposed to talk about when we shall be dealing with electricity and magnetism? It is a branch that deals with the relationship between electric field and magnetic field and their applications in the working of electronic devices such as motor, microphones, electromagnets, and many others. We have thermodynamics. Thermo, first of all, is the scientific word or term that refers to heat. So it deals with the transformation of heat to and from other forms of energy and accompanying changes in pressure, in volume, and other physical quantities. We have geometric optics. Optics is a scientific word that stands in for light. So it deals with the behavior of light as it passes through various media. Properties of light like reflection, refraction, and many others are studied in geometric optics. We have waves. Waves is a topic of its own. We have waves 1 in Form 2 and waves 3 in Form waves 2 in Form 3. And it deals with propagation of energy through space and effects such as reflection, diffraction of light, of sound waves, and many things. When we talk about waves, first of all, light is a wave, sound is a wave. So when we are studying about those, it's like we are studying waves. And we have a topic of light in Form 1, in Form 2, in Form 3, and also in Form 4. And all of these we are going to study. We have atomic physics. First of all, from the word atoms, this is where now chemistry interacts or relates to atoms, and we call it the atomic physics. It deals with the study of behavior of particles constituting the nucleus of the atoms and the accompanying energy changes. That is the atomic physics. Allow me right now. Physics is not an island. It's a subject that is being taught alongside other subjects, and therefore, what does it mean? It means that it must interact with the other subjects, so it must be having a relationship with the other subjects. So let's see how physics interacts with the majority of the subjects. I may not explain all, but I just give you a preview. For example, if they ask you how does physics relate to mathematics, we know very well physics has some calculation that we require some formulas, and these formulas we borrow from mathematics. Physics and chemistry, for example, when we are studying about the structure of the atom, in chemistry, that is a knowledge that is being borrowed from physics. So the two subjects interact. Physics and geography, for example, in geography, there are weather measuring instruments such as thermometer, we have rain gauge, and so forth. You know all of them, the ones which are found in a weather station. A geography person cannot make those weather instruments unless there is a knowledge of physics on the same, so they relate. We have these. Also, you can check on this: physics and history. I know you are wondering how physics and history. Historians will tell you that there is a fossil found in a given place, and this fossil has stayed for 5 million years. How do they know? They apply what we call the carbon dating. Carbon dating is a technology that we use X-rays. We use rays to determine the age of the fossil. So they will tell you a human fossil has been found that is dated back to 5 million years ago. What have they used? Carbon dating, which is the knowledge of physics. Yeah, physics and home science, for example. Physics and home science. Home science uses some electrical equipments. For example, electric cookers, microwaves, energy saving geckos, though it's not an electric equipment, but its knowledge or its way that has been made to save energy is because of physics. How it has been molded using a clay soil, which is a poor conductor of it, is a knowledge from physics. To prepare an electric cooker, even the word electric alone, it means it requires the knowledge of physics. Now let's look at the physics and technology. Physics and technology. Technology is just a subject like any other. It may not be taught in high school, but it's a subject like any other. It needs to be introduced back. So now, you can't imagine how the treatment took place 100 years ago and right now. Each day, there is advancement in technology, which is traced to the knowledge in physics. For example, X-rays, to know how the fracture has taken place in your body, or it can detect a fracture in your body, that one is a knowledge on physics. Most of us at some point, you've gone to hospital to undergo X-ray detection. It is a knowledge of physics, and it's also a technology that we need to embrace. Physics and biology, for example, how do they relate? Physics helps biology to make or to manufacture microscopes that they use to study diseases, study cells, microorganisms, such things. It is physics, so they relate. And many other subjects, physics and agriculture, they relate so well. Just to imagine. So please, just to know how physics relates to each subject. You can even decide to say physics and English relate, because we borrow English knowledge to discuss physics. Though physics can be discussed with other language, not alone English. Even in your mother tongue, we can explain physics. Now, do we study physics in vain? The answer is no. We study physics because we know after studying it, it will benefit us in a way. And how does it benefit us? Because after studying physics, you can pursue some careers. For example, education. I'm a teacher because I pursued physics in high school. But before we look at those careers, let's look at this. Let's look at a career, a course, and occupation. Those three terms needs to be differentiated, explained, and know what is a career, a course, and occupation. A career refers to a job or a profession that one has been trained for and intends to do for a long period of time. For example, my teaching career, medicine, engineering, electrical technician. I've done education to teach physics, not for 1 year or 2 years, for a very long period of time. Even if I will not teach forever, but I know it will take place for a long period of time. A course refers to a lessons in a particular subject. Lessons in a particular subject is a course. An occupation refers to a job or a profession. My occupation is teaching, and my career is a teaching career. I'm a teacher. Yes. So some of the examples that we actually, the courses that you can take when you pursue physics in terms of degree, that is at a university level, including the Bachelor of Education Science. You can be a teacher of physics, Bachelors of Science, that is civil engineering, Bachelors of Medicine, Bachelors of Architecture, Bachelors of Technology. So the word bachelor stands for degree. So when you hear about a bachelor, it's like a degree. Now, it's not a must that you take a degree course. You can take a diploma course. For example, diploma in civil engineering, diploma in computer science, diploma in water technology, and diploma in laboratory technology, amongst many others. We've just given you few examples that you can see. So that is about the career. So let me tell you, you are not studying physics in vain. You are studying physics so that you can better your future. You are studying physics so that you can save this generation. You are studying physics so that you can save humankind. Physics is a practical subject that it requires to be done in a laboratory. So allow me to take you through some small concepts about laboratory or about physics laboratory. Any science subject, biology, chemistry, and physics has a laboratory where practical lessons take place. So what is a laboratory? It's a special room designed and equipped for conducting experiments such as physics practical. In physics laboratory, you will interact with the three main systems or three major systems. The first one is gas piping system. For example, where we obtain the laboratory gas, we require some heating. The second one is electrical energy supply system. We require some electricity in the lab. If you have gone to the lab, you understand what I'm talking about. Water system. There must be water in the lab because there are some practicals like floating and sinking that requires water. There are some cleaning that's to take place in the lab that requires water. So the main systems in the laboratory are gas piping system, electrical energy supply system, and water system. Lab also is a very delicate place whereby sometimes accidents occur and it doesn't end well. So what do? What happens is there must be rules that should be followed, not only by the students, even by the teachers, the lab technicians, or anybody in the lab, which if you fail to follow, accidents may occur, poisoning may occur. So let's see some of these laboratory rules. Before you start interacting with the lab, note the following. First of all, know the location of electrical switches, firefighting equipment, first aid kit, gas supply, and water supply systems in the laboratory. Know where they are. I will tell you why as we are moving on. Windows and doors should be kept open while working in the laboratory. This is for free circulation of air. Any instructions given must be followed. You have to. Whether you are used to not following instructions, in this place you have to follow. Never attempt anything while in doubt. You better consult your teacher or the lab technician. There should be no eating, drinking, or chewing in the laboratory. Ensure that all electrical switches, gas, and water taps are turned off when not in use. This enables saving. When handling electrical apparatus, hands must be dry. You know water is a good conductor of electricity. Just try touching electricity with wet hands. You will get shocked. Never plug in foreign materials into electrical sockets. Shirts and blouses must be tucked in and long hair tied up. Keep floors and working surfaces dry. Any spillage should be wiped off immediately. Let me repeat point number 9. Shirts and blouses must be tucked in and long hair tied up. If your hair is disturbing you, you cut off the hair. You remain with very short hair like this one of mine. That point was written for the sake of the girls students. All apparatus must be cleaned and returned to correct location of storage after use. Yeah, so after using it, clean, return it. This one should be followed by all the students. I see most of them, they wait for the lab tech to assist you. No, it's like at home. After eating, you take the apparatus, you take the utensils where it should be, even here. You return the apparatus where it should be. Laboratory equipment should not be taken out of the laboratory unless authorized. Some of you will take the stopwatch. Please don't. Any waste after experiment must be disposed of immediately. Yes, any waste. Waste is whatever you will not use again. Hands must be washed before leaving the laboratory. Why? Some of you touch chemicals that they end up licking their hands, forgetting it's poison. Take care. Those are just few amongst many other rules that we must follow in the laboratory. Now, accident is accident, and sometimes in the lab, it has to occur. So what happens is, when accidents occur, how or what do we do? We call it the first aid measures. First of all, I want us to see some of these accidents that can occur in the lab. Then we see what causes them and what to respond, or the first aid measures in each case. We have cuts. What causes cuts? Poor handling of glass apparatus and cutting tools, such as scalpel and razors. You seek assistance to stop bleeding. You apply what you call immediate dressing of the wound. We have burns. You can be burned by chemicals or naked flames. What do you do? In case you are burned by chemicals such as the acid or base, you wash with cold water the affected area as you are looking for further treatment. We have poisoning. Inhaling poisonous fumes, or you accidentally swallow chemicals. That is poisoning. But it only has one first aid measure. That is, you seek medical assistance. That is it. We have eye damage. Bits of solids or dangerous chemicals can enter to your eye. Then it will be a very serious accident. So what do you do? In case of such irritating chemicals, you wash your eye with a lot of clean water. Electric shock. Touching exposed or naked wires can make you get electric shock, or using faulty electrical appliances. Now, that's why I was telling you at the first rule that you are supposed to locate the main switch. When your friend, it can be your teacher, lab technician, is on a shock, please run to the main switch, put it off. That is the first aid measure. Then you come now and attend to your friend. So those are some of them. Let me give you some exercise here before we end the lesson. Name 3 branches of science subject in the secondary schools. You know it, that one we say it. Explain the steps involved in scientific approach. Explain the steps involved in scientific approach. Let me challenge you. Please put this answer in the comment section. Explain the steps involved in a scientific approach. Kindly list them, the steps we follow. Name and briefly explain the branches of physics. Name and explain all the branches of physics. You are a serious student. You can do it. Give instances where physics is interdependent with agriculture. I may not have mentioned this, but apply the knowledge gotten from the other subjects. Now, there is a table here which I can ask you to, it is giving you all the topics that you are supposed to study in Form 1, Measurement 1, Force, Pressure, Particulate nature of matter, rectilinear propagation of light and reflection of at plane surface, thermal expansion, heat transfer, electrostatics 1, simple cells and electric circuits. Simple cells and electric circuits can be said to be electricity 1. So now, we had mentioned some of the branches of physics. Can you please put this topic into the correct branch? I can do it one for you. For example, I can just pick one like thermal expansion. Then I tell you that this thermal expansion is a topic in Form 1 physics that falls under a branch of physics known as thermodynamics. That is it. And that was the end of my presentation. I urge you that next time also check for the next lesson. This is Ambassador Foundation. Kindly subscribe, share to all Kenyan students. Thank you.